So now for our final installment segment on types of relationships here, we're going to look at inverse variations or inversely proportional. So it's kind of sort of going to be the opposite of direct variation or directly proportional. Now if a direct variation is a special kind of linear relationship, then a inverse variation or inversely proportional relationship is going to be a special kind of nonlinear. So if you wanted to think of it this way, if this were linear relationships, then direct variations or proportions would fit inside linear relationships. And if you were to think about nonlinear, over here, inside that would be an inverse variation or inversely proportional. Okay? So you could think of it that way if that helps you out. Now, back here. So x times y equals your constant there. You could also see it in this format as k divided by y equals x, or you could even have k divided by x equals y. Now that does not make a whole lot of sense until you look at a table. And a table helps this put it into something that makes more sense. Okay, so we're going to multiply here straight across. Now if I do that, I'm going to get my k, my constant. All right, so multiply straight across. 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6, 24. 6 times 4, 24. 8 times 3, 24. 12 times 2, 24. 24 times 1 is 24. Okay, so notice that we have the same product when I've multiplied straight across. If you tried to find the slope from this, you would get all kinds of weird and strange things. Not going to get the same thing. So that should tell you that it's not a linear relationship. But then when you check your products straight across, you're going to get the same constant. So then you know that that's an inverse variation. Now, an inverse variation is going to be the inverse of a direct variation. So if a direct variation is a straight line through the origin, then the inverse variation is going to be the opposite of that. It's going to be not straight, and it's going to kind of avoid the origin, if you want to call it that, because it's the inverse of direct variation. So here's what it looks like. It usually, they'll just show you the first quadrant, which is up here, and it looks something like that. Okay, it gets close to the axis, the x and y axis, but it never crosses. Now if it shows you all four quadrant, the entire Cartesian plane, then it would look something like that. It would have both of those. Okay? Now, still doesn't make a whole lot of sense until you put it in a situation. So let's pretend that Mike is having a pizza party at his house, and he invited everybody in his math class, and there's 23 other people in his math class. Now, if he's the only person that shows up to his pizza party, he's going to be sad, and he's going to eat all 24 slices of that pizza. But if another person shows up, he's going to share that pizza, and each of them are going to get 12 slices. There are 24 slices total. Can't eat more than that, than what you have, okay? So one person gets 24 slices, two people gets 12 slices each. 3 people are going to get 8 slices of pizza each. 4 people will get 6 slices each. So I could go on down through here with all of the factors of 24. And if we have everybody show up from his math class, then everybody's only going to get one slice of pizza each. Maybe probably still be hungry. So what I want you to notice here that should stand out to you about an inverse variation is as the number of people increase, the number of slices of pizza they can eat each decreases. So your variables are going to go in opposite directions. That's something that should stand out to you about an inverse variation. They go in inverse directions, so if one goes up, the other goes down. Okay, one variable increases, the other variable decreases. And this works when you have a set amount to work with, okay? So if I'm going to travel a set amount of miles, let's say I'm going to travel 360 miles, the number of hours it takes depends on how fast I travel. So as I travel more quickly, it takes less time. If I travel slower, it's going to take more time. Hopefully that'll make a little more sense to you as we practice. That's all we have for all these different types of relationships. Please make sure that you get this attached into your journal. You can fold it to where you can see this. If you want to fold it in half again, you can. You can label it types of relationships. Make sure you get some glue on the back of this and insert it into your journal. Put some glue back here, insert it into your journal. So then you have this as a reference to use for the remainder of this year. That's all we have for types of relationships. Thanks for listening.